All right, good day, everyone. This is Jason Strait with the PaaS Cloud Virtual Group. We're here today for our session, PaaSport to Paradise, Lifting and Shifting with Azure SQL DB, Managed Instance, and Azure Data Factory. Before we get going here today, I just have a few announcements. So the first thing is, let me actually get off the GoToMeeting. There we go. First thing is, this virtual group is sponsored by Microsoft. They help to support putting these webcasts together and bringing us sponsors and other benefits to this group. If you are not yet a member, we do have a page at the PaaS site for this virtual group. It's at cloud.paas.org. The nice thing about that is you have an opportunity there to log in, to subscribe, and then once you've subscribed, you get our newsletter that comes out usually about once a week. And that has all of our upcoming presentations along with some other announcements. Speaking of upcoming sessions, we have 7 more that are currently scheduled over the next month and a half. Always looking for more, so if you are interested, you can email at me at cloud@paas.org and send your information about what you'd like to present on over to me. Alternatively, you can fill out a form. We actually have 2 more that are being scheduled right now based on folks that have submitted details for a session. So that's a great way for you to reach out and share what you know about bringing and building cloud data platforms. If you did miss PaaS's Summit for 2019, you can get all of the recorded conference sessions. There's over 230 sessions that were recorded. You can get those at the PaaSstuff.com website, and it's a good way to get caught up on everything that was talked about at the PaaS Summit. And this virtual group is part of a number of virtual groups that PaaS helps to support to give people the opportunity to learn more about building data platforms. So there's some that are focused on different aspects of technology, like application development or database administration, and there's others that focus on native languages, such as Global Spanish and Global Chinese, giving folks an opportunity to learn in their native language. Throughout this session, if you have questions, please type them into the question panel. As we go through, Sandy will look at, as he finishes each section, he'll be asking for questions, so please type them in as we're going through. Any that are left over we'll go through at the end. And with that, I'm going to hand things over to Sandy, our presenter today, in his session, PaaSport to Paradise, Lifting and Shifting with Azure SQL Database, Managed Instance, and Azure Data Factory. So, Sandy, let me make you the presenter.
Thank you, Jason.
There we go.
Show my screen. So can you hear me okay? And can you see my screen?
Yep, I can hear you fine and can see your screen. So I'm just going to mute myself so I don't interrupt you.
Great. Okay. So let me introduce myself first. My name is Sandy Binarco. I'm the Principal PM for Azure Data Governance team. We are based in 3 locations, Redmond, Microsoft headquarters, Shanghai, and also in India. My team is specifically based in Shanghai, and we are focused on the development and integration of SQL Server value-added services. So specifically SQL Server Integration Services, SSIS, Master Data Services, MDS, and Data Quality Services, or DQS. And we are, in fact, responsible for the integration of SSIS into the cloud data platform, which is Azure Data Factory. So today's section is essentially an extended version of my Ignite session that I did in Orlando last November. The agenda will be, I will go through a quick flash introduction for those who are, probably most of you are familiar with SSIS, but might not be familiar with Azure Data Factory or ADF. And I'll go through a quick learning objective of what you can get out of this session today. After that, I will go through the best practice recommendation of how to migrate and lift and shift your ETL workload to the cloud using an all PaaS and SaaS solution. And then I give you a bit of a background how we evolve SSIS from an on-premise traditional ETL platform into a cloud platform as a service integrated with ADF. And then I'll get into a deeper technical discussion on the access method for SSIS in Azure Data Factory to reach down to on-premise data sources. because once you have your compute in the cloud, you will need to be able to still reach down and ingest data from traditional on-prem data sources. Okay, and after that, I will go through basically the playbook how to migrate all your SSIS packages and jobs from SQL Server and also from SQL Server Agent to the cloud, either into a SQL Managed instance, which is the target database migration destination, or into ADF, which is the Azure Data Factory for the ETL workload. And then I will go through all the demos. I might actually mix and match the demo between sections, so that way we don't go through like a very long pure content presentation. Okay. So after that, let's go through the first section, which is the flash introduction. So most of you probably know already SSIS is a traditional ETL tool that comes bundled with SQL Server. It's mainly used by our users to ingest and transform and load, basically extract, transform, and load data from or to SQL Server on premises. Usually, SSIS is traditionally used to with a SQL Server, and a customer mostly wants to manage their own infrastructure on-prem. ADF, Azure Data Factory, is actually a cloud-native ELT platform as a service. ELT is a different pattern of data integration, where you actually extract and load first into the cloud, into a staging area, which is normally Azure Data Lake or a data lake store, where you can have various type of data, structure and unstructured, relational or non-relational, and then you actually transform it and then ingest it into a data warehouse. This pattern, ELT or a modern data warehouse pattern, is the purpose of the creation of ADF. A lot of our SSIS customer has already a lot of ETL workload or packages on premises. When they want to run these packages in the cloud, usually the challenge is really hard to transform or convert 1,000 or 100. We have customers who have like almost 100 or 1,000 of packages created on-prem, and to transform this workload into an ADF native data integration pipeline is almost virtually impossible. If I may use an analogy, it's like you have SSIS on the ground floor, and then you have ADF on the 7th floor. Converting all the packages at one go is like jumping seven-story high, which is virtually impossible. And for that purpose, essentially, we create a SSIS in ADF. SSIS in ADF is an integration of SSIS inside ADF, where ADF have offered a special compute resource or compute engine where it can actually execute SSIS packages in the cloud. So with SSIS and ADF, you can almost see it's like you can transform step by step, or you don't even have to transform any of your packages. You can run your packages as is with minimal or no change in Azure Data Factory, and then you can actually modernize it step by step at your own pace. So that's the purpose of SSIS and ADF, is to remove all the friction when you want to modernize your ETL platform and run it in the cloud. Okay. The learning objective of this session is like I will probably repeat this mantra all over the session. Essentially, I want you to learn about to lift and shift your ETL workload with little or no change, with no friction, using SSIS and ADF. We offer full compatibility of all your packages and SSIS jobs to run in the cloud. Once you lift and shift your ETL workload in the cloud, you can modernize it, combine it with Azure Data Factory native features, and you can start opening the door to big data patterns or modern data warehouse patterns. And then if you find that like the built-in components that we offer in SSIS or ADF does not fit your purpose, SSIS itself has an unlimited extensibility platform. So essentially, you can extend your workflow with third-party components or open source component, or even you can build your custom component and integrate it into the cloud. So the takeaway from this session is you can first lift and shift, and then you can modernize and extend your workflow at your own pace. All the interface is ready for you to do exactly that. On the lift and shift itself, there are 3 steps that I will go through the demo to show you. First is like to prepare the PaaS infrastructure, so it's ready for your workload to be migrated. And then I'll show you the tools to do a batch migration, to migrate not only the package but also jobs into the PaaS solution. And then finally, you can operationalize your workload that's already running in the cloud using Azure DevOps and ADF orchestration layer or scheduler. Okay. Let's go to the best practice recommendation of how do we actually essentially it's like a 20,000 feet view to see how SSIS fit into the ADF and how the all PaaS solution is more beneficial when you want to run your ETL workload in the cloud. Okay, we start with your SQL Server estate on premises. Usually your SQL Server has 3 main value-added services. In here, the three VAS is SSIS, which is integration services, SSAS, analysis services, and SSRS, which is the SQL Server reporting services, right? When you want to basically retire your SQL Server on-prem and run it in the cloud, the first thing that you should consider is finding out what are the PaaS solution that available for you. PaaS has more benefit than infrastructure as a service because you don't have to manage the infrastructure itself. It's all managed by Microsoft. We do all the security patches, basically the upgrade of the platform, etc. So it should have a lower TCO for you, which is the total cost of ownership. Okay, so the first all PaaS solution that you need to consider is combining the Azure SQL database, which is the database engine PaaS in the cloud, or managed instance in this case, which is the variance of Azure SQL database that has close to 99% compatibility with SQL Server on-prem, and SSIS in Azure Data Factory, which is also has almost 100% full compatibility with SSIS on-prem. Now, once you use the all PaaS solution for SQL Server and SSIS, the other value-added services, unfortunately, we don't have a full compat solution, but we do have a partial compatibility solution. For example, for the SSAS, the analysis services, we do have the cloud service PaaS, which is called Azure Analysis Services, AAS. But this PaaS service for analysis for AS only support tabular model. So if you have a multi-dimensional model, you still probably have to use the SSIS on a VM in the cloud or leave it on-prem. For SSRS, the reporting services, right now, the recommended solution is to completely replace it with Power BI, because we don't have a plan to have a PaaS solution for SSIRs. So usually most of the presentation of SQL migration stop in this slide. But what I want to focus right now is actually on the SSIS in Azure Data Factory that can serve almost as a glue that connect all these different resources in the cloud and on-prem. If you can see, within SSIS in Azure Data Factory, there's a lot of components that can connect to all these services in the cloud and on-prem. For example, if you're still running the multi-dimensional models of your data with SSAS, we do have SSAS components that can refresh your multi-dimensional model running in the cloud, for example. If you have AAS, then we do also have AAS components. If you run Power BI, the Power Query script that you create with Power BI can be run on SSIS in Azure Data Factory. We have recently released a new component which is called Power Query Source, such that the Power Query script, the PQ script that you create from Power BI or from Excel, you can just simply cut and paste it and run it on SSIS in Azure Data Factory. And as you can see, the Azure SQL Managed Instance, or the MI in this case, serve as the storage for packages. So your SSISDB can be stored in Azure SQL MI, while the SSIS running in Azure Data Factory can still reach down and connect to your SQL Server on-prem if you still want to manage some servers on the premises. And I will show you how to actually reach down from the cloud, accessing data on premises using SSIS in ADF. So once you run your ETL workload in the cloud, now you are open to modernize your ETL workflow. For example, ADF has a native 80 plus, or I think recently we have added 10 more, about 90 plus connectors. So SSIS has probably about 40 plus connectors built in, and ADF has 80 plus. So once you run SSIS in ADF, you can actually combine SSIS package with other components of native ADF components. So you can have like almost a hybrid SSIS and ADF data integration pipeline where you can combine different transformation, different data connectors. And if those built-in components does not fit your they don't fit your purpose, you can always, like I mentioned before, you can extend your workflow with our partners component, or even a custom component or open source component. Those are in the bottom are most of our partners who have actually adapted their components to run on SSIS in ADF. Some of the components are actually deeper integrated. For example, we have recently released a Sentry One Task Factory, where you can actually integrate that components without actually installing the component using a script, for example. I will talk about more customizing the SSIS in ADF using all these different components, extension or additional components later. All right. Before I move to the evolution of SSIS in ADF, is there any questions so far? It might be, I might talk too fast, or
Jason? Yeah, no questions quite yet.
Oh, yet? Okay, good. So let's go deeper into the SSIS evolution from on-premise to cloud. As you know, probably SSIS has been around for a long time. It's been around, I think, more than 20 years. It started as a DTS, I believe, which is called Data Transformation Service, and then I think in 2005 it got renamed as SSIS, and essentially we start improving it, and we're making it it become one of the most popular ETL platform on premises. All right. The one that I want to highlight is the year 2017, which is almost like a Big Bang year for us, because that year we launched 3 major features. The first one is essentially we have this we actually provided support for Linux, so you can actually run SSIS on Linux. So if you want to run SQL Server on Linux, you can also have a SSIS running on Linux. And we introduced a scale-out topology, or a scale-out feature, where you can actually install SSIS on multiple machines in a master worker architecture. And this is actually provide the base for us to create a platform as a service. So not only you can actually manage your own scale-out architecture on-prem, but if you want Microsoft to manage it, we announced also in 2017 the first integration of SSIS in Azure Data Factory, which is a PaaS scale-out feature. So the way we do it is essentially we separate, we split storage from compute. If you are familiar with SSIS, you usually store your packages in the same instance of SQL Server where you run your workload, right? In the cloud, though, the storage and compute is actually 2 different services. So the package can be stored in Azure SQL Database or managed instance, where SSISDB is hosted by them. Or if you use the package deployment model, we just recently also released a feature to support file system. So you can store your packages either in SSISDB, in Azure SQL Database or managed instance, or in Azure Files. The compute of SSIS will go to Azure Data Factory. So Azure Data Factory has created a special compute engine that's capable to run SSIS packages. And this compute engine is called Azure SSIS Integration Runtime, or for short, I will call it SSIS IR from now on. Okay, and when we do this, we want to make sure when a customer run their workload in the cloud, they don't have to learn too many new things. So we want to be able to support our customers such that they can preserve their skill set. So we want to make sure that all the existing on-prem tools like SSDT and SSMS, they are all Azure enabled. So you can actually use SSDT to design your packages and run it in the cloud. I will show you the interface, the new SSDT version, where you can actually run package locally or run package in Azure. So that way you ensure that your package is compatible to run in the cloud before you actually deploy it. And SSMS and also Azure enabled, where you can actually create schedules based on and you can actually create automatic Azure Data Factory scheduling or pipelines and activity from SSMS. I'll show you also that interface. And all the legacy command line utilities that you are familiar with, like DT install.exe, DT util, and DTXX, most of them are also Azure enabled. For example, DTXX is a very interesting case, because a lot of some of our customers that we learn, they don't use a SQL agent to orchestrate or schedule their jobs. They are actually using some of our third-party or our partners orchestrator. For example, they use Tivoli or ActiveBatch, and those third-party orchestrators is actually invoking DTXX. So for us to make sure that they don't have friction when this customer wants to keep using those third-party scheduler, we actually create a new command line utility which has the similar interface with DTXX, which is called Azure DTXX. And this actually automatically will create a pipeline activity and run the package in the cloud instead. So from the interface point of view, you can still use a third-party orchestrator, but now your workload will run in the cloud. Okay, and on top of that, we also add the new interface to design, deploy, configure, execute, and monitor your packages using the Azure Data Factory portal. All right, and I mentioned before, we essentially, when you run SSIS on-prem, you can install anything you want, and you can run a different component on-prem. This flexibility we brought to the cloud also, such that with a custom setup interface, you can do the same thing. You can install anything you want, and you can extend the SSIS Integration Runtime as you see fit. And for third party, we provide a licensing model where they can actually still get their license to be validated and bound to the integration runtime in the cloud. And finally, let me talk about the pricing. For SQL Server, for SSIS, when it's bundled with SQL Server, it's always it comes free for SQL Server. But when you run it in the cloud, we actually charge it similar like a virtual machine. So it's charged per second, but the price is quoted in a per hour basis. But you can actually get a benefit of cost savings when you actually bring your own license. So if you already have SSIS running in on premises and you want to move your workload to the cloud, there's an option when you provision the SSIS IR to actually enable Azure Hybrid Benefit or AHB, and you can get a significant discount of running your workload in the cloud. This discount can go, depending on the size of the machine, it can go from I think 30% to almost 80 or 90%. I'll show you the price differences later. Okay. And after that, I will also show you once your workload is running in the cloud, you might still have some data stores running on premises. We have two different methods to reach down from the cloud to access those data on premises. The first one is through the VNet injection. So you can inject your SSIS IR into a VNet connected to your on-prem network, such that all your on-prem data stores has basically it can be seen from SSIS in the cloud. So SSIS has a line of sight to all those data stores, and it can extract data from it or load it. Another way of doing it without using VNet is using a proxy. So essentially, a proxy is a self-hosted integration runtime where you can actually install a mini SSIS engine behind your corporate firewall that will actually connect to your data stores locally. And once it connects to your data stores, it will move the data into a staging area in Azure Blob Storage, and then the SSIS IR in the cloud will pick up the data from the staging area to the final destination. I'll show you also that that flow using the self-hosted IR as a proxy. Also, I like to mention, once you run your SSIS in the cloud, you're open to all these cool new features that running in the cloud. For example, you can store your secrets or access credential using Azure Key Vault, and you can also connect using Azure Active Directory authentication that can benefit from ADF managed identity and trusted services. So in this case, like if you want to protect your stores, your data sources in the cloud, without actually requiring your integration runtime to join a VNet, you can use this security measures. Okay. Once you run your SSIS in the cloud, you can actually wrap it as an activities inside ADF pipelines. A pipeline is essentially a chain of activities. So you can combine SSIS activities with other ADF native activities, and you can do almost like a Lego approach, a mix and match to basically fit your needs. Right. And finally, it's already been GA for a while, almost 2 years now. And we have 24/7 live site support, and we have a lot of customers running SSIS in production. Essentially, this is like a really good way for you to explore running SSIS in the running your ETL workload in the cloud without too much investment of replacing everything. You can do it step by step using SSIS in ADF. All right. So before I go into the before I go deeper into the alternative methods for on-prem data access, is there any question?
Nope, Sandy, no questions at this point.
Okay, actually, I would like to break the session into a demo right now. So maybe it's instead of like going through the whole thing, let me just show you how to provision SSIS IR in ADF. Okay, let me just go to my Azure portal. Let me show you my. This is a quick demo of provisioning of the SSIS IR. This is my dashboard, my Azure portal dashboard, right? I have all my Azure resources provisioned already, and I have several Azure Data Factory provision. What I want to show you is like how to provision the SSIS compute engine within Azure Data Factory. So I will select one of the Azure Data Factory that already been provisioned. I click on that tile, and you go directly to the overview or summary page of the Azure Data Factory. And there's a tile called Author and Monitor. When you click on it, it's actually open the app for ADF. And within that app, you can essentially design your author your pipeline, create a SSIS integration runtime, etc. So when I click on it, essentially it's opening, but I'll show you just quickly what it looks like. Let me see. There you go. Let me just click. It's going to look like this. And there are 6 main action that you can do on the Azure Data Factory portal. The main one that I want to show you is essentially the configure SSIS integration. This is the place where you can provision your SSIS integration runtime to run your packages in the cloud. Right? When you click on this, it'll open a provisioning blade. There are 3 parts of the provisioning blade. The first one is the general settings. You provide the input for the computer properties. In here, you can say that you can put the name for it. Let me just put it demo SSIS IR decryption anything. The type is by default as Azure SSIS because this is the compute engine that can execute SSIS package. Location, we release I think about 26, I believe 26 regions so far. And the last one that we just released about a week ago is South Africa North. So we have Brazil, East Asia, etc. You can select all those regions where you want to run your SSIS integration runtime. And then you can select the node size. The node size is essentially you want to choose the same size similar to the size of your SQL Server. For example, if your SQL Server has 8 core, on-prem and you want to run the same 8 core in the cloud for your ETL workload, then you use the 8 core engine. Here we have all the way from, I think, from single core all the way to 64 core. You can see here, there's 1 core, all the way to 64 core here. And we also provide a different type of compute size. There's one that's like essentially general purpose. The other one is more memory intensive. They have bigger memory. You can show the dimension of the compute dimension and the memory dimension here. So you can choose what size that's actually better for your workload. Okay. And then the node number is the size of the cluster, where you can select all the way from 1 to 10. So you can have 10 VM running in the cloud, all ready to run SSIS packages in parallel. The parallelization of SSIS is actually at the package level. So let's say you have a 10 nodes provision in your integration runtime, and you have 10 packages run at the same time. When you submit a request to execute those 10 packages, the 10 nodes will pick them up at the same time and run it in parallel. So in this case, for my demo, I'll just use 1. All right. Oh, by the way, if you notice, when I do this, the price can be shown to you, can be displayed, so such that you can almost estimate like how much it's going to cost you. For example, here I have like 1 node. If I increase, you can see the price here. It's increasing, right? This is very expensive if you do that. And you can see like the cheapest one, like a I think D1 core. If I select there, the price goes to like a 50 cents per hour, something like that, right? Let me just go back to D8. The one that I mentioned before about saving costs is like when you bring your own license. So if you already have a SQL Server license running on-prem and you want to just use the same license to run in the cloud, when you click on that, you can see the significant savings that you have. You see? So the saving essentially means that you don't have to pay for a SQL IP anymore, so the SQL license anymore. You only pay for the compute, the raw compute, which is the number of cores and memory, and also the managed service, which is the service that we provide to manage your infrastructure. The edition, as you know, SSIS on-prem, you can run it with a standard edition or enterprise edition. Enterprise has all these advanced components like fuzzy lookup, Oracle connector, Teradata connector, etc. So when you do that, Enterprise is more premium, so it's more expensive because it has all these premium components. The thing is that you can notice, right? If I change this standard or enterprise, the price does not change here. The reason why the price does not change is because I already told the engine, the provisioning engine, that I already have a license. So essentially, when I choose an enterprise, I already have an enterprise license. So the price of the standard and enterprise edition is the same, which is the price of the compute engine and the managed service, because you already have the license. If I don't do this, if I don't have a license, then I have to pay the license in the cloud. The license in the cloud for enterprise is more expensive than standard. If I select standard, you can see the difference of price, right? It changed. So I'll select yes. So I'm going to bring my own license, continue. So now we are in the second provisioning blade for SSIS. In here, you can decide what deployment model you have on-prem. So like if you use a project deployment model where you actually deploy your packages into SSIS catalog or SSISDB, you check this checkbox. So essentially, this will show you here. There's a tooltips here. So if you check it, you're essentially deciding to run your workload with a project deployment model with SSISDB. But if you uncheck it, you're actually running it with a legacy package deployment model where you store your package in a file system, file share, or Azure files. So you can see if I uncheck it, you don't need to do anything, because essentially you just deploy your packages into a file system, file share, Azure files, and then SSIS IR will fetch it and execute it. Let me show you how to use the catalog. So when you want to run with the project deployment model and you want to provision SSISDB, we actually provision SSISDB for you, but you need to bring your own database server. So in here, you select your Azure subscription. Your location by default is selected the same location with your SSIS IR. Remember when I told you that when you provision SSIS in ADF, we actually split the database engine from the ETL engine, right? The database engine will be inside the SQL database or SQL managed instance, while the ETL engine will be inside Azure Data Factory. So you want to make sure these two services are in the same region. Because I select my SSIS IR in West Europe, then the SSISDB should be in West Europe. You can change it, but the issue is like if you do that, there will be a latency when you run your packages. The fact is when you run your package, you need to write your execution logs back to SSISDB, so that way you can monitor and you can check if there's any issue or not, right? That log writing, if you have your SSISDB in East US, for example, and then you have your SSIS IR in West Europe, there will be a cross-continental log writing, which is obviously will incur latency. So by default, we let you make sure that the SSISDB and IR is in the same region. Okay, and then once the region is selected, we will show you all the SQL DB server that you already have in Azure. You can select all these different one, right? You can select either a managed instance or the standard SQL DB. You can, I think, let me see if I can show you the managed instance here. I might not have a managed instance here, but in you can see the different naming. Usually, a standard SQL DB has 4 parts in the name, which is the name of the server, .database.windows.net. Managed instance has 5 parts, which is the name of the server, and then there's a DNS prefix, and then database.windows.net. Okay, so you select you bring your own server. Once you bring your own server, you need to give us your admin credential such that we can actually create SSISDB inside those database server. The way you do it is either you provide a SQL auth admin credential here. You can use the admin username and your password, right? Or you can use a AAD authentication. AAD authentication means instead of using SQL auth credential, you are using the Azure Data Factory managed identity to create the SSISDB inside your database server. In order to do that, there are steps that you have to provide permission to your data factory to be able to be like a DB owner, such that you can the data factory service can create SSISDB inside your database server. So if you click in here, you can see that the SQL auth credential will go away. You see. And then later on, then you can select the size of your SSISDB. You can select a basic size all the way to like I think there's a huge business continuity, hyperscale, etc. And you can even select Elastic Pool if you want to use Elastic Pool to host your SSISDB. Okay. So for this demo purposes, I will just use a basic package deployment model without SSISDB. So I just unselect this, and that's it. It essentially means that my SSIS IR will need to fetch packages from a file system or from files here. And then next is the advanced settings blade. This is the final blade, and in here, let me talk you through this. This is a bit advanced. In here, you can remember that I mentioned before, you can actually run packages in parallel in multiple nodes, right? Now, in this settings actually can tell you to can help you run packages in parallel within the same nodes. So let's say if when I select my nodes with 8 cores, if I want to run actually 8 packages in the same node, so like each package will run in a single core, then I use the maximum parallel execution per node 8, for example. And if I want to, for example, if I want to run 2 packages per core, I can go all the way to 16. So the limit that we provide is like 2 times the number of core you can run your packages in parallel. So with an 8 core node, you can actually run 16 packages inside the single node. Now, if you have 10 nodes in a cluster, then 16 package per node, you can actually run 160 packages in parallel at the same time inside the integration runtime. Okay. If you have a big package that you want to take advantage of all core, you basically want to dedicate all the compute resources into a single package. Let's say you have a heavy compute heavy sorting package, right? You can just select one. When you select one, it means all 8 cores will be dedicated to a single package execution. And you can keep changing this whenever you want to run your load. So essentially, you can dynamically change the parallelization of your IR. So for my case, I'll just leave it back to 8. And now there are 3 checkbox, which is an advanced setting checkbox. The first one is like I mentioned before. If you don't check the first one, which is the customize your SSIS IR, your SSIS IR will have all the default standard components built in and pre-installed. But if you want to install anything that doesn't come with the in the box, right? You just like this. In here, you have 2 interfaces. The first interface is the general standard custom setups. In here, you essentially need to put a shared access signature, uniform resource identifier, SAS URI, for your Azure storage blob container. So you actually have to bring your own Azure storage blob container where you store your custom setup script. So let's say you have a custom component that you want to install. You have to create a script how to install it, and then you have to upload that script into a container. Inside that container, you have the entry point for your custom setup, which is what we call the main.cmd script, right? And then with the main.cmd script, you can also upload other associated files with your custom setup, like a DLL, a batch file, executable file, MSI, Microsoft installer, etc., right? And then you take that SAS URI and you plug it in here. So what happens is, like when we provision your compute, we'll see that you want to customize your compute engine. So we go visit your blob container, we download all your custom setup script and associated files and every single node of your IR. And then that way, every single node of your IR is customized with your custom component. If you don't want to go through all this trouble and you just want to do a quick customization, right now we actually opening a feature that's like we will extend it more and more, essentially called Express Custom Setup. And Express Custom Setup is essentially you can customize your IR without script. In here, you can select new, what kind of Express Custom Setup you want to do, for example, right? And you can have select. For now, we have 3 types of Express Custom Setup. The first one is run a CMD key command. CMD key is a Windows command that can persist access credential on your compute, on your SSIS IR. So let's say you have file shares and SQL Server and different type of stores that require like your IR to use different access credential. You can run command key in there. If I select command key, you can see here. Right, this argument is essentially the same argument of running a command key on the prompt line. You can put your targeted computer domain name, your account name, and your account key. Right. The second Express Custom Setup is if you want to create a new Windows environment variable that you can use within your package. So let's say you want to use a new PaaS or something that you want to build with your script task, for example. You have SSIS with script task, and you want to use some Windows environment variable. You can add the environment variable here. Before Express Custom Setup, you have to do it actually through the script, which is the main.cmd script. Now you don't have to do it. You just simply enter what is the name of your variable name, the Windows environment variable, and what is the value. Right? The really nice thing that we have right now is also we are working very close with some of our partners, and we actually allow those components for the provided by our partners to be integrated and installed without a script. In here, let's see, if I select install license component, you can see there are, for example, now we have 3 components from our partners. One is from SentryOne. SentryOne has a Task Factory a suite of high-performance SSIS component that can be installed on your SSIS IR. Before this Express Custom Setup, you actually have to provide a main.cmd script with an MSI installer that could run the installation script for Task Factory. Now you don't have to do it. All you need to do is select this, for example, And then all you need to do is you just put the license key. So you work with you talk to SentryOne, you buy a license key to run their component in ADF, and you just bring that license key and plug it in. It's like bring your own license, also similar to like bring your own license for SQL Server. This is bring your own license for PaaS Factory or for other partners component. Okay. The other partners that we that have been integrated is OH22. OH22 is a ISV based in Germany, and they are specializing in a data quality component. So there are two data quality components that are now deeply integrated. One is what is called SQL Phonetics that will do a data matching and data deduplicating within SSIS IR, and HEDA.io, which is actually a data cleansing component. The HEDA.io is very interesting because it's actually aimed for migrating your DQS workload. So if you have data quality services that are already running on-prem and you don't want to have it running on-prem anymore, you can actually use HEDA.io, and you can migrate your knowledge database, the KB, the data quality knowledge database, into HEDA.io service, and then you can operationalize the data cleansing operation using SSIS in EDF with this HEDA.io component. Okay, so let me go back again. So that's what about those are all about the customization. Okay. Now the next step of advanced settings is a VNet. And here, if I select this checkbox, you can see, right? Here, essentially, you're telling us that you want to inject your SSIS integration runtime into a virtual network such that it can access data stores in the same virtual network. You do this essentially, for example, if you have SSISDB hosted in managed instance is always provisioned inside a virtual network. So for SSIS IR to be able to fetch packages from SSISDB inside virtual network, SSIS Integration Runtime or SSIS IR has to be also inside of the same VNet. Right? And if the VNet is actually not the same, let's say it's actually a different region, you have to do a VNet to VNet peering or VNet to VNet connection such that SSIS IR can reach down to the SSISDB inside the managed instance VNet. The other reason why you want to inject SSIS IR into VNet, like I mentioned before, is to access on-prem data. So when you can inject SSIS IR into VNet connected to your on-prem network, all your on-prem data stores in the on-prem network will gain the private IP range within the VNet such that SSIS IR can access it through the package running in SSIS. And in here, you select all the property for the VNet. The location is by default the same location as the IR, right? And the type of the virtual network is always ARM VNet, Azure Resource Manager. And then in here, you can select the available VNet. In here, I didn't create a VNet under this subscription, but if you do, you can see the VNet and subnet that you want to inject. And one new feature that we brought is actually also that we just released this, I think about 2 weeks ago, which is actually a bring your own IP, bring static public IP addresses for SSIS. This is used for when you want to protect your data stores with the IP firewall rules. So only a certain IP address can access your like your SQL DB, your storage, or etc. Right? When you do this, we will assign. You will have. You will bring your own public IP addresses that you provision on Azure, and then when you select that, I think it's still loading. In this case, in my, let me just see a different subscription that I can show you. Let me this one. This one should show you a lot of different. Yeah, see, in here you can see a lot of different VNet. Here you can see like all these different IP addresses that you can select. You need to bring 2 IP addresses. And always do bring a pair of static public IP addresses, because when we do a rollout, when we upgrade your IR, we do actually do a hot swap. So we actually use one IP address running your IR, the live IR, while the other one is to running the standby IR. So like once we finish of upgrading the standby IR, we swap from the production with the standby IR. So in this case, you always have to provide 2 public IP addresses, and these public IP addresses you can allow in the firewall rules of your data stores. All right. So that is the VNet advanced settings. Let me just uncheck that to show you not last advanced settings, which is the setup self-hosted IR. In here, essentially, you provision two IR. The first IR is a SSIS IR running in the cloud, and the second IR is the one that you have to install on your on-prem site. This IR that you install on the on-prem site is called a self-hosted integration runtime, and it can act as a proxy to access data on-prem. So in this case, if you don't want to use VNet, this is the way to access on-prem data. What you do is like you provide the name of the self-hosted IR that you already installed, right? And then you provide a staging storage link service. Link service is a concept in ADF, essentially to tell the access credential for the staging area. So in this case, the staging area is always an Azure Blob storage, and then the link service is essentially the account name and account key for your Azure storage blob container. And then you can also decide what's the name of the container, where your self-hosted IR will bring data from on-prem to that container, and then SSIS IR will pick up the data from that container to the final destination. So I'm not going to do all those in this demo. Essentially, I just show you what it can do, right? So that's it. So that is the advanced settings. So you see the compute setting, the deployment settings, and advanced setting. And then the next one is essentially the summary page. The summary page will show you all the settings that you selected in the beginning. This is the Azure Data Factory setting. General setting is the compute setting. Because I didn't select SSISDB, you don't see the SQL settings here. And then you can see the advanced setting that I mentioned before. And it also show you all the documentation links where you can actually learn how to deploy your packages. Because once your IR running, it's ready to fetch your package. But you need to deploy your package first, either to file shares or to SSISDB, right? You can click on this link for deployment. And you can click on this link to see the current prices, essentially to estimate the cost of running SSIS IR in the cloud. You don't have to run it 24/7 because you might actually want to build a pipeline that the just-in-time provision, such that you can provision your IR just before your package is executing, and then the provision or stop your IR right after the package execution. And you can learn about it in this link, the stop and restart it whenever convenient, or schedule it just in time. Okay, and that's it. When you click create, it will create an IR. And in here, you can see all my, I'll show you how many IR I have created for this session. The demo SSIS IR is essentially the one that we just created. It's starting. It should take under 5 minutes. It should be ready. It's pretty fast. When you don't inject it into a VNet, it should be pretty fast provision. This one is a normal IR. Let me just see if I can just show you the name. The My Azure SSIS Integration Runtime is a normal IR connected to SQL DB. My SHIR and my SHIR2 is a two self-hosted IR that I installed on my laptop and my desktop. And the last one is actually an IR integration runtime with managed instant hosting my SSISDB. So they're all ready for demo. And once you provision it, you can see. I'll show you the monitoring. There's this. You see this dial icon. When you click on it, you're actually monitoring that IR. For example, this IR is still being provisioned. You can see in here. Takes a while. Yeah, you can see here. It's still starting. The type, the location, the spec, the size, right? And it's still. I'll show you one of the IR that's already running, and I can show you the monitoring page for that resource. Let's see this one. Oh, wait, let me just go back here. Where is that? Give me a second. This one. Okay, I click on it. Let's see. Yep, this one is running. You can see there's one node requested, one node, and it's running. This is the name of the node, right? And there you go. Oh yeah, there's a link also here. If you want to stop your IR, you can just click on this link. You see, you can execute SSIS package is essentially creating an automatic pipeline and activity. I'll show you later on this one. You can stop if you want to stop your IR. Essentially, it'll warn you like if you stop your IR, if you have any package running, it will be automatically canceled, right? You don't want to do that. And then here, the resource ID is the resource ID of the IR. And usually you use this when you buy, you can use this with the ISV. If an ISV support SSIS IR, oh, there you go. The demo SSIS IR is already been provisioned, so it's finished. That's pretty fast, right? Going back to the resource ID, you use the resource ID to buy a license for your custom component, for example. So you can buy Task Factory. You can provide this ID to Sentry1. Sentry1 will give you a license, and then you use the license later to provision your IR. In here, you have a link to the database server where you host your SSISDB. You can see here, right? And this endpoint, the name of the DB in my case is Sawinark SSISDB.database.windows.net. That is the endpoint that you use to connect SSDT and SSMS. When you connect SSMS to that, you can actually execute package in Azure. Because what SSMS will do, will send a tsql command to the SSISDB to create execution and start execution on your SSIS IR. And then there's this link to manage the size of your SSISDB. Let's say your SSISDB fill up with the execution log and you want to resize it, make it bigger. That link will take you to the Azure portal where you can manage the SSISDB itself. Let me see, it's opening. It's take a while. Anyway, this basically will open Azure portal where you can manage your SSISDB. It's a bit slow. There you go. Yeah, see, this is basically the page where you manage your SSISDB. You can clean logs. You can resize it from. I think by default I always provision a service tier of S1. I can increase, upgrade it into S3 or hyperscale, etc. Okay, so going back to the connection tab to show you all my IR, you can see all my IR is running. So I have actually 1, 2, 3, 4, 5 IR, 3 SSIS IR and 2 self-hosted IR. Okay, so far on this demo, any question?
No, Sandy, no questions yet.
Wow, that's good. So far, so good then. Is it okay? Do I speak too fast or too? From your point of view, Jason, is it the flow is okay, or is it too fast?
Oh
or
yeah,
too
the
slow?
flow's great.
It's okay, right? If you have any question, just let me know. Just type.
And actually, we did have one just come in. Are all self-hosted IR? Do all self-hosted IR have to be in sync?
Oh, what do you mean by in sync? In sync means like it always have to be running, right? Because in order for your package to run using self-hosted IR, they both have to be running. It's connected. Essentially, self-hosted IR is connected to SSIS IR. What do you mean by in sync? Is like online? It has to be online because it has to be connected to Azure Data Factory, such that Azure Data Factory can keep upgrading the self-hosted IR and sending a job to execute packages on the self-hosted IR. Does that answer the question?
I think so. There wasn't a follow-up, so I believe so.
Okay. Okay. In any case, at the end of this session, I'll give you all my email address, and you can elaborate more on your question and send me more. Okay. All right. For that, after a provisioning demo, I'll go back to my deck and I'll follow up with a deep dive into the on-prem data access. Okay. Let's see from current slide. So like I mentioned before, there are two ways of accessing on-prem data. The first one, you can see Data Factory in the cloud. The first one is basically injecting your SSIS IR in this on the right-hand side. You have to inject your Azure SSIS Integration Runtime into a VNet connected to your on-prem network, such that the package can actually reach down and reach down to your data store on-prem, and then load it into the cloud, or depending on your workload, it should be able to like reach down to the on-prem site, right? The other way to do it is actually, instead of injecting your IR into VNet, you use two IR. The first one is what we call the self-hosted IR here in the bottom on the left-hand side. That is where you install your self-hosted IR behind your corporate firewall on-prem. That is the one that access your on-prem data store. So in this case, it's accessing the source. It could be SQL Server or file share, right? And then when you execute the package, the whole thing is controlled by Azure Data Factory. So Azure Data Factory will send a control a request to execute a package on a self-hosted IR. That package will actually move data from the source into a staging area in Azure Blob Container, and then Data Factory will tell SSIS IR in the cloud to pick up that data from the staging area and move it to destination, with transformation in the middle, or depending on the package design. So there are two ways of accessing on-prem data, right? Now going to the VNet one, this is the more complicated one. The VNet injection is very flexible, but when you want to have a lot of requirement for security requirement, it's actually a bit more complex to configure. The pros, the pros, and there are pros and cons for two methods, right? For the pros for VNet injection is like everything is a managed infra, so you don't have to manage your self-hosted IR, right? Self-hosted IR, you have to put it in on the machine, and you have to manage the machine yourself. With the SSIS IR injected into VNet, the compute itself is managed by Microsoft, right? And it support all connectors. You will see later, I'll show that the self-hosted IR feature only support a few connectors, because in order for us to support that feature in all different connectors, it takes a while for us. So like that way, we have to actually prioritize, I think, SQL connection and file connection first before we go to different connection to enable this self-hosted IR as a proxy. With SSIS IR, all connectors are supported, and obviously there's no staging, right? With SSIS inside of VNet, all data movement is direct, so it should be faster. The cons is the difficult or complex configuration. For once, the account that provisioned the IR has to have the right permission to join that IR into the VNet, the specific VNet. The address range, depending on the size of your IR, you have to make sure, like let's say a 10 nodes IR will require a larger IP address range for the subnet where you injected the IR. And for example, if you want to use custom DNS server, you have to make sure that that custom DNS server can resolve the fully qualified domain name of all Azure resources, and make sure that you have the backup, or like a auto resolver, which is Azure DNS as a secondary DNS server. If you want to isolate your VNet to make sure that only approved traffic can go through it, and then you have to actually introduce a lot of network security group, NSG. The NSG is essentially those orange arrow here. For example, you have to, if you want to close your VNet, you need to at least open an NSG for port 443, because the IR inside your VNet need to be able to communicate to Azure Data Factory, to Azure Storage, to Azure Container Registry, to Event Hub. All these backend services are required to run your IR inside your VNet. So that means you have to open the port for that. One thing that's really sometimes is difficult to fulfill is like when a company has a very strict corporate policy that doesn't allow inbound traffic. Outbound traffic is more or less okay, but inbound traffic is required for our underlying infrastructure, which is using Azure Batch here on the left-hand side, Azure Batch Management. That is actually an inbound traffic inside your VNet to be able to manage your the nodes inside your VNet. So that means you have to open an NSG for that special port, 29876, 29877, such that Azure Batch underlying infrastructure can manage the IR inside your VNet. Right? There are ways to make sure that like only certain IP addresses from Azure Batch that's allowed, etc., etc. But it is a complex configuration. Right? And if you have a company that wants to do auditing of all the traffic, that means you actually want to divert all inbound and outbound traffic into a network appliance or a firewall where you can actually audit it, right? In that case, you have to make sure you add a user-defined route for this inbound traffic Azure Batch, because the Azure Batch cannot be rerouted into a network appliance, because if you do that, then your IR will break, right? So that's all this complexity depending on how strict is your corporate network policy. And for example, if you have a corporate network policy that lock the resource group, you have to make sure that like for this subnet, you have to unlock the resource group, because when you start and stop your IR, Microsoft or Azure Data Factory should be able to create and delete certain network resources to manage the platform as a service, right? Some of these network resources are like the public IP, load balancer, and NSG. If you have a resource group that lock, then we cannot delete it, and we cannot delete it, then your IR will break. So those are the cons. The cons is basically complex configuration. The pros is all the good stuff there, the full connectivity, right? Now, if you move to the next method to access on-prem data, this is much simpler. The process, the configuration is very simple. It's like an MSI you install on your on-prem machine, and then suddenly your self-hosted IR is like running. It'll connect to ADF, and it'll be coupled with SSIS IR. And each package that you run, if you want to enable the proxy feature, you just enable one property. So let's say you have a ETL moving data from SQL Server to Azure Blob, for example, right? And on the OLEDB connection manager, there's a proxy that called connect by proxy. If you enable that, it essentially tells us that like the packet has to be executed first on the self-hosted IR and then later on the SSIS IR. If you don't enable that property, everything has to be done on the SSIS IR. Right? And obviously, it can reuse all the ADF native link service for the staging area, reusing the Azure Blob Storage link service. The cons is obviously, like I mentioned before, the machine itself, you have to manage it, because it's not a PaaS anymore. It's an IaaS, infrastructure as a service. If you run it on a VM or you're running it on an on-prem machine, so you have to manage your own machine. Right now, and there's also limited connectivity for self-hosted IR, because right now we only support. Actually, we've just extended it now. So we have ODBC. I didn't put ODBC yet, but the update is like we support ODBC, OLEDB, and flat file sources right now. So if you have a relational database like MySQL, PostgreSQL, SQL Server, or anything that can be connected with OLDB or ODBC, or a file system or a file share, then you can use a self-hosted IR as a proxy. We have a customer, for example, running a Snowflake on-prem or running Snowflake in the cloud, right? They need ODBC, and then we can actually use self-hosted IR with a ODBC source, for example, to connect to a Snowflake. Another con is basically because it's staging, so the data movement is actually two-step. So first step, first staging task is moving from on-prem to Azure Blob, and then the second one is Azure Blob. So there's some latency. Azure Blob to the final destination, there's some latency in that data movement. All right. All right. So any question on that before I continue?
Yeah, the one question that did come up is what is it about the two that cannot connect to each other?
What is it? What you mean, like how they connect to each other?
Yeah, there's two of them that you mentioned that couldn't connect to each other, and unfortunately, the question came in right as I was looking away, so I didn't catch which two they were. So if whoever asked the question could ask a clarifying question.
Okay, so
yeah,
maybe let me just guess. Maybe how the self-hosted IR can be connected to SSIS IR? If that's the question, is like I show you in the provisioning demo before. In the provisioning demo, you actually have to tell when you provision SSIS IR, you have to tell which self-hosted IR can be coupled with it. When you do that in the back end, we'll make sure that those two work together, right? And then all you need to do in the package is just enabling this connect by proxy property. Everything else, it will be will be done by the backend, because the backend will know like this SSIS IR coupled with self-hosted IR. If the connect by proxy is enabled, we'll split the package. It's actually what we do. We actually split the normal package. There's an ETL package, right? The ETL package will be split into E and TL. The E will be done by the self-hosted IR. The TL will be done by SSIS IR. I hope that answered the question. If not, that please elaborate that other question, and then I can answer it.
The two refers to the two self-hosted IR that can't get connect.
Oh, the one that I showed you before.
I mean,
yeah, I show two self-hosted IR, right?
Yep.
There's the one that's running on my laptop, because I install a self-hosted IR on my laptop, and also I install my SHIR2 running on my desktop. So I can actually have a choice, either using depends on where my on-premise data stores, right? If my on-premise data store is like closer to my desktop, then I use my desktop as my self-hosted IR. If my just for in case, if I'm using a SQL Server on my laptop, I install a SQL Server on my laptop, then I can use my laptop as a self-hosted IR to connect to the SQL Server on my laptop. So essentially, it's very flexible. You can connect any self-hosted IR with any SSIS IR, and you can share them. By the way, you can have one self-hosted IR shared by many different SSIS IR. One to many sharing.
Okay. And then there's one more follow-up question. I'm just trying to get the whole thing here. On one self-hosting to, one self-host serving to connect on-prem server, and the other sites on Azure to connect to
anything.
Okay.
Correct. So the self-hosted IR is only to connect to on-prem data stores. In this case, database server or file systems, right? And then one is the SSIS IR to connect to everything in the Azure, or even outside Azure. Like for example, if you have like a store in Amazon Cloud or Google Cloud, as long as you have a way to connect it using ODBC or connection, right? Then you can do it also.
Right.
But remember, the self-hosted IR is only used if you don't want to use VNet. What we recommend is, like, if you don't have a VNet complexity and you think it's easy to set up a VNet, the VNet is more is recommended by us, because the VNet, there's no latency, there's no staging, right? And there's unlimited connectivity, because all connectors are supported by VNet injection. Only ODBC, OLEDB, and flat connection supported with self-hosted IR.
All right, sounds good.
Yeah. Okay. So let's move to the next subject, which is let me see what's the time. We still have 40 minutes, right? Why don't I go to the demo? Let's just do a demo quickly. So
sure.
Yeah, let me see, where should I go? I show you before provisioning of SSIS IR, right? And then monitoring of SSIS IR. I want to show you how to deploy package. So now I will open. I'm opening my SSDT. This should be familiar with you, and you can see there's I have this projects called scale out project, right? In this scale out project, I can actually deploy all this my project into SSISDB, or if it's a package deployment model, I can deploy it to a file system or a file share, right? What I want to highlight is the fact that this new version of SSDT is actually Azure enabled, because it's connected to my Azure SSIS Integration Runtime. You see here, I can actually, you can see this and in fact, once I'm connected to my Azure SSIS Integration Runtime, which is the same one that you see on my ADF portal. I'll show you back to ADF portal. See this one? See the third one. The third one, the third SSIS IR is actually connected to my SSDT, such that any of these packages in my project can be run on the cloud. So now when you right click on something, let's see here, like this package. This is the package that I have, a simple ETL, right? It's basically taking data from table 3. Table 3 is essentially look like this. I'll show you quickly. Yeah. Table 3 is basically a list of fake customer name, and then has first name, last name, street, postcode, city, and country. This is table 3, the source, right? What it does is like it's gonna create a fifth column, which is full name. It will combine first name and last name with a space in the middle, right? The space in the middle is actually turned into a variable, such that I can run it later on and change the space into some different symbol, right? And then store the result in the table 5. So I can run this package. Sorry. Here, execute package is normally run a package locally. Basically, my laptop will run the package, right? But now I can run the package in Azure. When I run the package in Azure, it's actually running inside the SSIS Integration Runtime that's connected to my SSDT. What it does is actually it will take that package from my SSDT, put it into a storage, Azure storage in this case, right? And then SSIS IR will fetch that package from Azure storage and execute it. So I'm going to run it. I will show you the result. Give me a second. So the result should be in table 5. This is table 5, right? It's still empty. Yeah, it's still empty. This is the result should have the 1, 2, 3, 4, 5, 6, 7th column with the full name. Okay. Let me run it on SSDT. Run in Azure. Actually, let's see. Hopefully it works. It might take a while because it's actually go to the cloud, put the package in the cloud, right? And then once you put the package in the cloud, it will signal to SSIS IR in the cloud to fetch the package from Azure storage and run it. So essentially, it's similar like running locally, but using the Azure compute. Let's leave it while it's executing and waiting to fetch result. What I want to show you also is, let's see, what can I show you here? Oh, deployment. Let's see. Once you can run it from SSDT, you can run it from SSMS. In here, remember I show you that this IR. Let me go back again. This my Azure SSIS Integration Runtime has an SSISDB hosted in this database server, right? This database server is SSISDB SSISDB.database.windows.net. On SSMS, I'm actually connecting to that one. Let me just show you here. SSISDB SSISDB. This is essentially the database server hosting SSISDB for that IR, right? I'm going to show you. I have already deployed packages into that SSISDB. And I can also execute packages from SSMS in the cloud. Essentially the same way like you normally do. You right click and then execute. Let me just show you all the package. See, this package is the same one. Oh, let's see. It's finished. So the running in Azure from SSDT is finished. Wait. Let me just stop. And you should be able to see the result actually. Let me just run this again. See the result? So full name is actually first name space last name. So this is actually running from SSDT in the cloud. Now I can do the same thing. Let me just delete the result first. Right? I can run the same thing, but now from SSMS. I use the same package that's already been deployed to SSISDB in my database server, right? Click, execute. It should have the execute dialog pop up. What happened? It's a bit slow. There you go. It's a bit slow, sorry about that. I just click OK. You can see the reason. And here with SSMS, you can see all the monitoring result of the package. So essentially, all the interface that you are familiar with on-prem, you can use it for running SSIS in the cloud. It's done already. So let's go back. It's the same. Execute. See, the same, right? So you can run it from SSDT, you can run it from SSMS, all of them run in the cloud. Let me just delete this just to make sure. Okay, so that is running. Now what I want to show you running an SSDT. Let me see, what can I show you here? I want to show you running from ADF portal actually. So you saw I run it from SSDT in the cloud. I run it from SSM in the cloud. I'm going to run it from from ADF portal in the cloud. So in here I go to the authoring tab, right? In the pipelines one. I think it's, I believe, pipeline 6. So here I open a pipeline that already have my package here. This service is actually a pipeline authoring service. I have already add an activity which is called execute SSIS package. You can drag and drop the activity from here, for example. You see, you can have execute SSIS package. You can drag and drop it. Yeah, I won't do it, but I don't need that. Let me just refresh. Discard all changes. Okay, so in here you can so this is, for example, here is the pipeline design service, right? I will show you. I can create pipeline variable, for example. You can see I have created several pipeline variable, like a source table, destination table. Now I'm actually changing. I'm using the pipeline variable to change the destination from table 5 to table 6. Right. Let me see what else in here. And then I can use. I can go back to the SSIS design service, and I'll show you all the tabs. Here, for example, the setting is showing you it's using SSIS IR, my Azure SSIS Integration Runtime to run it. And you can select if you want to run Windows authentication or 32-bit runtime. For example, you have some components that can only run in 32-bit. You can check that, for example. And if you have on-prem data store, or it's like, for example, the on-prem SSIS, the analysis service, it requires Windows authentication. So you can actually check that and enter here, like here, you can check. You can enter the domain username and password. And if you don't want to put the credential in here, you can actually use Azure Key Vault. Azure Key Vault is it's a secure features where you can actually store your secrets. So if you close here, for example, you can see you can have you can select the AKV link service. You can put the secret name, blah 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 blah. Okay. Let me just go back. Not using this. In here, you can select the package location for the SSIS activity. By default, this pipeline I already use SSISDB, but you can see here I have 4 different locations. So SSISDB is where you deploy your package into with a project deployment model. If you use the package deployment model, you can actually fetch the package from file system, which is a DTSX package file, or you can actually store ISPEC file, ISPAC file, and you can actually select a ISPEC file and then select the name of the package in a file shares. Right. The last one is the embedded package. Is something that I will show you later. This is very cool. You can actually drag and drop a package from your Windows Explorer onto ADF to execute. Okay. So let's see. I don't want to publish. Let's see what else I can say. Oh, and the parameter in here, I want to show you that, like, remember this package when I design it, right? The name of the table is actually parameterized. Now, when you parameterize it, it will appear in this tab. So all your parameter that you design in the package will appear in this tab. So in this case, the destination table was table 5 before, but now I'm actually assigning a pipeline variable, which is table 6, to the destination. Now, when I run the package from ADF, the result will be in table 6 actually. In here, you can see all the connection managers that's used, right? There's a Savinax SQL DB, Savinax SQL DB2, which is the same as this one, SQL DB. So basically, whatever you design with the SSDT will appear on ADF once you deploy it. And you can overwrite any of the connection string if you want. The one that I want to highlight is the property overrides. In here, remember, I create a variable in my package, which is actually a DRV column expression here, right? Here, the DRV column expression is a variable which is essentially the space between first name and last name. Now I'm actually replacing the space with $3 sign, right? Now, if I run the package, the result will be in table 6 with a $3 sign between first name and last name in the full name column. Okay, let me just refresh it again. Discard all changes. Okay, and I'm gonna run trigger now. Okay, and you can see now the destination variable is assigned by the pipeline variable now. If I run, it's running, pipeline running. You can actually monitor the pipeline, the running pipeline here in the monitoring page. So you have this my pipeline 6 is still running in progress. Click, it succeeded already. So you can see here the activity, right? So what I'm going to show you is actually the result first. Oh, sorry, it's not table 5, it's table 6. It should be in table 6 now. Give me a second. There you go. You can see the full name is actually first name, $3 sign, last name, right? And all running in ADF. It's actually executed from ADF portal, where you can override all this property, connection manager string, connection string parameter, etc., etc. Right? The one that I want to show you also is actually the execution ID. If you look at the ADF here, this is the activity basically wrapping the package execution, right? If I click on the output, you can see the SSDB operation ID is 365. You can link this to the SSMS, because if I refresh this, you can see the operation ID is 365. That's just being run. See? So that's linked to the ADF portal where I run the package. Okay. What else? Let me see. That was running from SSISDB. I can show you run. I think it's pipeline. What is pipeline 5? Let me show you. Oh, this is actually. I'll show you later. This is actually a pattern where you can actually start your IR before you're running a package or a store procedure, and then stop your IR. That's essentially cost management. So you only pay what you use. So essentially, you on-demand provisioning or just-in-time provisioning of your IR based on your package execution. I'll show you that later. Which one is the good one not to show? Pipeline 9. This is, let me see. Oh, this is not the one that I want to show. I think I show it here. Let's say pipeline 1 has something. Yeah, this one I'm using file system project as the package location, right? So in here, instead of showing SSISDB as a location, I'm actually showing aspect file that actually stored in my file share. I can show you my file share. I think it should be, where should it be? Yeah, that's the one. So I'm going back to my Azure Storage Explorer, so I can show you all different container and folder inside my Azure Storage. So there's this file shares in Azure Storage. It's called Savinark file share, where I put my packages and my project file, aspect file that I can execute using my ADF. It takes a while. There you go. So in here, as you see, there's all these packages. Right, I can run packages, so basically selecting the package location as a package file or project file. In this case, in my example, it's a project file. Right, the name of the package is the same package that we ran before. On top of that, I changed the protection level from encrypted by user key to encrypted by password. So in this case, I put my, actually no, let me see. I didn't. You can actually, if you do that, you can actually put your package encryption password in this field. And this package access credential is the access that you can use to the credential that you can use to access this file share. What else? And you can provide the logging path where the log, because we're not using SSISDB now, we're using the package deployment model. So you need to store the execution log somewhere. So you can actually provide a file share and a log folder, right? What else do I do in this? Connection manager. Yeah, the connection. This is what I'm saying. Because my package by default is encrypted by user key. When you run it in the cloud, you need to actually override that with the sensitive value with something with actual value. Either you put it the value in here or use Azure Key Vault to store those secrets. On a property override, I just override the same variable that signify the space within first name and file name of last name into a 3 exclamation mark. Okay, let me just run it. So now it's running using ADF, and it'll fetch the package from my file share. So instead of SSISDB, right, and running in the cloud. Let's see. Still in progress. Hopefully it runs. Let's see. Where I want to go. I want to show you the result here. It should be table 5 still. Yeah, there you go. You see the result is full name is actually first name 3 exclamation mark last name. So here the package is actually located in a project file .ispec file stored in a file share. Run from ADF in here. See if I refresh it, it should show that it's finished already. Yeah, it succeeded. Okay, let's see what else I can show you. Oh, I want to show you the embedded package. I believe this is this one. So my pipeline 10 is actually using a location from embedded package. And this is where the cool thing. This is the same package, except this package now is a switch protection level into encrypted by password. And you see the embedded package. I actually already drag and drop the package in here, or you can actually upload the package from anywhere. let's see. Demo scale up project. Yeah, see this package? Either I can upload it from here or I can drag and drop it here. You see? I can just drag and drop from my Windows Explorer to my ADF like this. There you go. And essentially the package is compressed and embedded into the pipeline, ADF pipeline. Now let me just refresh it again. Discard all changes. Let's see. Yeah, so and then I change because I changed the protection level, I have to provide the encryption password to decrypt the package when running in the cloud, right? And this is all the log folder. I think I don't change anything else. I'll probably change the property override. Now I use 3-star as the space, right? So I'm gonna run it. Now I'm running from ADF, the same package with a different protection level, encrypted by password, and it's actually embedded inside the pipeline. So I don't have to bring my own Azure blob, I don't have to bring my own file share. I don't have to bring my SSISDB. I just embedded the package from my laptop to my ADF and run it. Let's see it succeeded already. That's very fast. Let's see the result. Oh, I didn't even delete this one yet. So these are all still the result with the previous result. If I just run it, it should show the 1000, I think, at the bottom. Yeah, see, there's a result with the 3-star, first name, 3-star, last name. Okay. What else can I show you? Let's see, go back. Let's go back. I think for now, I think it should be okay for now. Maybe I should open the floor for a question. Is there any question on the executing from SSDT, from SSMS, from ADF in the cloud?
Yeah, there was just one question. Is there, and I think you did answer this one. Is there a central place to see all package running history on different types of IRs?
Yeah. Here, what I showed you before, the monitoring, this is the pipeline running, right? If you go on the SSIS IR, let me see. Yeah, see, it showed the activity on the integration runtime. So this one, well, all these 3 demo, I'm using all the same SSIS IR, right? Which is the my Azure SSIS Integration Runtime in East US. If I have different IR, it will show here like all the different activity and different IR, and you can sort it by the name of the IR here in the activity monitoring page, basically. Okay.
Yep.
All right. Let me go back to the deck. Let's see. Okay, now I'll just talk about a little bit about the premium or advanced extension. This one I'll just talk a bit quickly because we already covered most of it actually. Let me just do quick. So premium advanced SSIS feature for extension. And as I mentioned before, SSIS IR come in 2 editions, an enterprise and standard. The enterprise one has this 5 group of premium or advanced component. Change data capture, Oracle Teradata SAP connectors, SSAS and AAS connectors, fuzzy grouping, term extraction, etc., etc. The one that I want to highlight is the Oracle and Teradata and SAP DBW connectors. Those connectors comes with the SSIS IR, but it needs an external driver. Oracle will need an OCI driver from Oracle. Teradata will need a TPT API driver from Teradata. SAP will need a DLL from your SAP installation on your local machine. So in the past on-prem, you essentially install that on your local machine, right? But in the cloud, we need to provide an interface for custom setup. Those interface is the one that I showed you before using a SaaS URI. So basically, you put all those driver into the Azure Blob container and provide the SaaS URI when you provision the SSIS IR. And here, essentially, you have to make sure that, like, when you do the standard custom setup with script, right, you have to make sure that the SaaS URI has a read and write permission. The write permission is especially important because when we install your custom setup, we need to upload the custom setup logs back to your container so you can debug it. So because it is your custom setup, it's only you who can debug it. So all these logs will be uploaded to the same container. So that means the SaaS URI that you provide us need to have a write permission, and it should also have a long life. Because like I mentioned before, the SSIS IR will always upgrade it by Microsoft. We'll add it more feature. When we upgrade your SSIS IR, essentially we release the node and reprovision a new nodes. And when we reprovision a new node, it starts with a vanilla node, standard node, but then we have to reach out to your container again to customize it. So that means your container and SaaS URI and all the resources needed for custom setup should have the same life cycle period like your SSIS IR. In that case, it's always accessible by your SSIS IR. Okay, and let's see, what can I talk about this? Oh, something that I need to talk about, the third-party licensing. On-prem, when you install a third-party, the old ISV components, they usually use a standard a machine signature of your local machine or your machine where you install SSIS, right? Essentially, you're using the MAC address or CPU ID of that machine. That standard method to bind the license into a machine does not work in the cloud, because, like I mentioned, in the cloud, the machine is keep reallocated, right? It keep being released and reprovisioned, released and reprovisioned. So you cannot depend on those traditional machine signature. So what we do is we provide two variables. One is a Windows environment variables, and the other one is a SSI system variables. And those variables can be used to bind your license and validate your license. So bind your license at installation time and validate your license at runtime. And those variables, what we call cluster ID and cluster node count, is invariant. It does not change whenever your IR is pre-provisioned, resized, etc. So those are third party or ISV will need to adapt their component to use these two variables in order to run on SSIS IR in ADF. Okay. So this is like a typical setup. You interface with your ISV, you buy a license key, right? And then you install the license key with the MSI inside the custom setup through the custom setup interface. When you run the SSIS IR, the SSIS IR will connect to your ISV activation server. This is a typical, not always the same, but normally it does this process this way. So the ISV, the SSIS IR node will actually connect to ISV activation server, download the activation key, and then we'll write the activation key into a local store or a registry, such that now that node is bound by the license. And then when you run the package with that component, the component of the ISV will actually check the same registry to see if the machine is actually licensed to run that component. So license binding and license validation is all done on SSIS IR through this method. Okay. And they use the variable that I mentioned before, which is the cluster ID. The cluster ID is essentially an ADF name and SSIS IR name in one string. Okay, and these are all our partners that already agree to adapt their components running on SSIS IR. I need to add one more because it's a bit slightly updated, out of date. We have also Varigens. Varigens is a partner that built a BIML, so BIML markup language, right? And Varigens actually also agreed to adapt the BIML engine with SSIS IR, so you can actually in the future you can actually install a BIML BML interpreter or BML engine on SSIS IR, so you can like cut and paste a BML script on SSIS IR. So that's very exciting development that hopefully happen in the next couple of months. Okay, for that, any question on advanced extensions setup or custom setup on SSIS IR?
No questions.
No? Okay. Can you tell me how much time I still have left?
About 15 minutes.
15 minutes. Okay. Now I will talk about the SSIS migration playbook. Right. Before I talk about the SSIS migration playbook, I will talk about the process of migrating your workload to the cloud. Right. So normally you have a DBA who actually will first access the existing packages. Most customers have like hundreds or thousands of packages that are already running a long time on-prem, and when you want to run it in the cloud, you want to make sure that it's actually cloud compatible. So there's a assessment process that usually done by the DBA, and it uses a tool that we provide, which is called the Database Migration Assistant, or I think Data Migration Assistant, or DMA, or we also are extending SSDT to do this assessment. Once you assess the package, you identify the one that's actually incompatible, and then you go through this cycle of edit, test, and assess, edit, test, assess. That's usually done by the BI developer, right? They're usually using SSDT to change some connection string. For example, if you on-prem packages using a hostname is not recognized in the cloud, so you have to change hostname into a UNC path or IP address, etc. So you have to make some changes in the package. Sometimes you don't have to make any packages. If your package is fully compatible to the cloud, then you don't have to edit it, right? Once you make sure that all the packages are compatible, then you just do batch migration. Batch migration, depending on your package, depending on your deployment model, you can either use a DMS, database migration service, to batch migrate to managed instance or SQL DB, or use SSMS. That we will actually add this feature on SSMS to do migration or redeployment. Or if you use package deployment model, you can use the familiar command line utility like DT install or DT util to deploy packages to file shares. So that's the process for migration. Now, what is the state of migration capability from on-prem to the cloud for SSIS? So this is essentially the migration playbook. Migration playbook is a 4x5 matrix. Let me see. I will show you. They are basically showing you all the recommended action that you need to do based on where you store your packages. For example, if you store your package in SSISDB in a project deployment model, the assessment can be done with DMA. So I highlighted all the recommended action that's available right now in green, while in the future it's still black, and the near future those feature will be green lighted also. Okay, so like to do a batch package assessment, you can use DMA. And then to do a package migration, you can move from SSISDB on-prem to SSISDB in the cloud using DMS, right? And job migration. Job migration is essentially those orchestration schedule in a SQL agent. If you have a lot of hundreds of SQL agent jobs, you don't want to recreate it, right? You can actually move that, migrate those SQL agent job into a SQL MI agent, or in the case of SQL DB into ADF. For example, Azure SQL Managed Instance has a native scheduler, which is called the MI agent, Managed Instance agent, right? While Azure SQL DB doesn't have a native scheduler. So in this case, the job from SQL agent on-prem should be migrated into Azure Data Factory when it can be orchestrated by Azure Data Factory. And the method to do that is essentially using script, and we can provide a script for you, either PowerShell, T-SQL, or C# to migrate jobs between SQL agent to MI agent or ADF. Now, if you store your package in a file system, it's the same thing. The action is like for package assessment, you can use DMA. And then for package migration, you essentially deploy all those packages to file share or Azure file using the normal command line utility. And in fact, you can actually also use Azure DevOps. I'll show you the Azure DevOps integration to deploy packages. This is really cool also. And if you don't want to redeploy it, you can keep it in the file system on-prem, for example, and then your package will need to fetch, your SSIS IR will need to fetch a package from on-prem by using VNet injection or self-hosted IR as a proxy. Like I mentioned before, you can actually not only access data, but also access packages on-prem using those two methods of on-prem data access. Okay. Job migration is the same. You can use script to move jobs from SQL agent to MI agent, and also on the side. So like you can see, like the action actually different depending on your destination of your migration. If your destination of migration for SQL is actually SQL MI, then the package migration and job migration action is different if you're compared to the destination is actually Azure SQL DB. Okay, if you have a legacy packages stored in a SQL Server database like MSDB, those are the action that you can do. I think we will share this deck with you so you can follow up, and then you can actually ask question from me. In this case, though, because we don't support MSDB right away in the cloud, for example, we don't have an MSDB to MSDB migration tool yet, or at least a DMS is not enabled to do that yet. What you can do, what we recommend, is actually switch to file system. So you can actually export the package from MSDB to file system, and then go to the second row to follow the recommended action for a package stored in the file system. The same thing with the legacy package store. You remember in the old SSIS, you can actually store packages in SSIS package store that you can connect to SSMS, right? Right now, the plan is to support ADF package store, where you can actually migrate packages from SSIS package store to ADF package store. But while it's being prepared, it's not ready yet, you can simply export packages from SSIS package store to file system and then follow the recommended action in the second row. Okay. And that's it. Do you have any question on the, do you have any question on the migration playbook? Jason?
Oh, sorry, I didn't unmute myself. Sorry, no questions on that, but there was one question that I think you did answer. Any plan to let ADF connect to SQL MI private endpoint if they ADF and SQL MI are under the same subscription?
Well, it's already available, right? Because if when you say ADF, depending on the IR, so if the IR is SSIS, I already mentioned to you with VNet injection, SSIS IR can connect to MI already in the VNet in the same subscription, right? Or even in this different subscription, because all the VNet, all the SSIR need is the access credential and injected into this in the same VNet and subnet of the in the same VNet, not in the same subnet, because the subnet cannot be shared, but in the same VNet with the MI. If you use only ADF, because ADF has another IR which is called the Azure IR. This Azure IR can only do copy activity or data flow, but they cannot do SSIS. This one does not support VNet injection rate. So right now it cannot connect to MI. The Azure IR cannot connect to MI. The only one that can connect to MI is MI in a private endpoint is SSIS IR or self-hosted IR. Does that answer the question?
Yep.
Okay. All right. Let's see. I think this is a list of demo that I should have I should show you. I think I showed most of them already. Oh, did I show the project deployment model? The project deployment. Let me maybe I can show that. Project execution. Okay, let me show you a deployment quickly. So if I use a SSDT, for example, right? I can just use right-click on the project, deploy. And here I'll show you the new interface. When I do this, you can select either deploying that project into an on-prem SSIS in SQL Server or SSIS in Azure Data Factory. If I select SSIS in Azure Data Factory, means I'm deploying the SSISDB hosted by SQL DB or MI, right? If I select that, then it actually asks you if you already have an SSIS integration runtime attached to that SQL DB or MI server. You can do that here. So essentially, you can provision SSIS IR through SSDT or SSMS, or through the ADF. The demo that I'll show you is provisioning IR from ADF. Here I can show you provisioning through SSDT, right? As you can see. But in here, what you do is like we will give you all default default property values. Like for example, if by default it'll be a D8, 8 core, 1 node or 2 node, etc. And then you have to actually go to ADF portal to customize that. Well, if you do it in ADF portal, you can right away from the beginning to customize it by yourself. Okay. And then in here, if I select next, then you just enter the endpoint. This is the endpoint of the database server where you want to host your SSISDB. And you need to use a SQL auth to connect to it. Let me just put my credential just to show you that it can connect. Okay, when I connect, it will actually show you that I have already the same project deployed there. You see the warning, a project with this name already exists, because I did it already last night, so I'm not going to do that. But this is essentially how you can deploy your project to SSISDB in the cloud. Okay, so that is the demo on deployment. Oh, I want to show you scheduling also. Let me just use quickly scheduling. I have 5 minutes, right?
Yep, 5 minutes.
Okay, let me just show you a quick scheduling. Remember when I let me just close all this pipeline before, just to clean up my service. Okay, things in here. Remember before I can tell you that you can combine SSIS package with a different activity in ADF. In here, I have a pattern of pipeline with 3 activities. The middle activity is basically the SSIS package execution wrapped into an SSIS activity, right? The left-hand side and the right-hand side is essentially web activity. A web activity is like it's an activity native to ADF that can invoke a REST API. So if I click on it, you can see what it's actually doing. In the settings, there's a REST API here, and the REST API is actually start. It's a starting an SSIS IR, and then you provide all the property for the SSIS IR, right? And here in the stop, it's the same thing. I can show you in the stop is essentially a REST API to stop my SSIR. So when I combine this pattern, I can actually start my SSIR just before I execute the package, and when I finish on completion of my package execution, I can stop my IR. So that means the cost of your running your IR is limited to only the package execution. This is how you manage the cost, for example. And then you can trigger, you can actually create a schedule, and you can actually let's see here, new or edit, right? You can choose a trigger, a new, I have created some of them. In here, you can have a schedule trigger, tumbling window trigger, or event trigger. Event trigger is really interesting because this is actually, you can use this to trigger your pipeline based on file arrival or file deletion. You can see here. Event in the blob, you can see the event that arrive can be blob created or blob deleted. So essentially, when you have a data arrive on your blob, then you can run your SSIS package. And in fact, not only just SSIS package, but you run the pattern, the just-in-time pattern. You have a file arriving on your storage, it will trigger an event to start your IR, execute your package, and stop your IR. So that is one way of creating a schedule, or you can do a traditional schedule trigger where you can see the recurrence like a start date, you can minute, hours, daily, weekly, monthly, blah blah blah. This is the interface similar to SQL agent scheduling, right? And that's how you provision. That's how you orchestrate your pipeline using ADF. Last time, before we finish, I'm going to show you the Azure DevOps integration. So here, remember this package, right? If I go to the Team Explorer, I actually already connect my project locally with my project in Azure DevOps. If I click on dev.azure.com, we'll open this. It's actually already been opened. It's the same thing. So in here, you can see I have a build. We actually support 2 tasks that you can actually run on a self-hosted agent, Azure DevOps agent, right? There's a SSIS build task and SSIS deploy task. The build task is essentially building either a manifest file for package deployment model or aspect file for project deployment model. The release, which is a release pipeline, is actually using the deploy task to deploy it into your SSISDB or your file share. Let me see if I can run this. Let's see, how do I do this? Oh, I want to show you first the SQL, the demo. In here, I have empty, right? Let me see. Let me just close this first. So I have this database server with SSISDB. I'm going to deploy using Azure DevOps. Can I just rerun this? Let me see. Sorry. I was just using it yesterday. How do I create a... Let me try. Succeeded. Releases. It's just showing the monitor of yesterday. Agent job. Oh, edit, sorry. Edit pipeline. I just want to show you the edit pipeline, sorry. It's so slow. Oops. It's so slow. But anyway, it's a bit slow. But anyway, I just show you like basically Azure DevOps can be integrated, and you can actually build your project file and your, let me see, is it done yet? Not yet. You can build your project file and then you deploy it to your SSISDB or file shares. Okay, I think I'm running out of time. I want to show you my email just in case we can follow up if you have any question. Slow down. Where is it? There you go. Phew. That's the last slide that I have. So my email is there. There's a Yammer group discussion that you can join also if you want to contribute to our roadmap, and there's a blog site you can visit. Okay, right. Thank you for coming. Sorry, I ran out of time, and I think the DevOps is a bit slow to show. Next time I can show it better.
Oh, no problem. This has been great. I'll be honest, I wasn't even aware of a lot of this, so this is great for me. I hope it's great for everyone else.
Great.
And Sandy, thank you for presenting here with us today.
You're welcome. And just send me emails if you have any question or feedback or issues. We'll look forward for you to use these features, and we base our development on your feedbacks. Okay.
All right. Well, thank you again.
Thanks for joining.
Bye. Yep.
Okay.
Bye.
Bye-bye.